We have some math workshops we're going to go over. Yes, we do have a quiz today, but no, the quiz is not going to take the whole class period, so we've got to get over this. I also want to look at your workbook assignment because I had someone come in with a good question. So if someone had their workbook handy that I can hold. Look, your workbook. Where's your workbook? I need someone's workbook. Thank you, ma'am. Okay, so I want to go over these math workshop questions. But first, yesterday we were talking about determinants, and I gave you an assignment from page 41. So I want to look at that now. We decided finding the determinant of a 2 by 2 is really easy. So I really bet Abby's going to do the 2 by 2s by hand by circling the diagonals, multiplying. She understood that, so she probably will work the 2 by 2s by hand. However, the 3 by 3s, it says, evaluate each determinant using diagonals. So I guess I need to change those directions. We did talk about 3 by 3s yesterday, but we decided we were only going to use what? Yes, dear? Calculator. You can have a point for that. So even though the directions say diagonals, seriously, I'm just expecting you to type it in your calculator.
Did you ever send them that link to learn how to do it?
I did.
Did you?
I did. If you go online and you want to learn that, you can. It's not a bad idea. It still just involves, if you like it says, it ends up involving diagonals. It's not hard. It's just literally typing in the calculator is faster, and we're going for the fastest route at this point in time. Or if you always wanted to, you could Google the top directions, say Kramer's rule. So you could always just Google it yourself, matrix Kramer's rule. Okay, so I did want to talk about that because someone in third period was confused about the directions. So seriously, just use your calculator. Oh, goodness gracious. There was something else I wanted to talk about. Oh, yes. When you get done today, instead of putting your calculator in the calculator holder, I need you to put your calculator on my desk. Does anyone know why?
So you know they're all there.
Well, I know they're all there when they're in the holder. Why do I need them on my desk today instead of in the holder?
Check them.
No? Okay, I teach algebra 2 tricks. I got it. You can have a point. I got to clear them out. I do not need Alex to work hard on this quiz and then someone to use his calculator next period and have all these matrices magically typed in. So while I trust you and I bet you will clear them yourselves, I'm going to double check since it is a quiz today. So put them somewhere in my vicinity and not in the holder because I assume the holder ones are good. Do not confuse me, please. Okay, so that was my one request. When Seth finishes his quiz, because he will, it's a fast one. When he finishes his quiz, he needs to work on his 2 workbook assignments. I still have not seen, I didn't even change the directions because I still have not seen everybody's page 39 or their new page either. So anyway, moving on. I'm needing help with these. I would love for your group to get an easy 5 today, maybe higher. What can I break 80 down into? 40 and 2 do multiply to 80, but neither of those are perfect squares. I need a perfect square. Table 5, go down a point. Y'all have yet to get out math. Hello, dear. He told me. Okay, hello, Earth to people. People to Earth. 8 and 10, neither of those are perfect squares. 4 and 20, but neither of those. Well, 4 is a perfect square, but there's a bigger one. I heard it, but I need someone to say it a little louder. Yes, Kelsey, 16 and 5. So I'm going to break 80 down into 16 and 5. I know the square root of 16. What's the square root of 16? Oh, my goodness. Whew, bless you, Abby. You can have a point for that. Okay, so a 4 comes out. And a 5 stays in because he doesn't get to go out because we don't know the square root of 5. So I end up having on the out side 16, and there's a square root of 5 under the house. Miss Compton is yet to deal with those variables. The variables get to come out, and if so, what are their exponents? It's q to the watt power. Thank you, Mia. You can have a point. Table 5, go down another point. What about g? G to the watt power. But it was 2 to the second under the radical. Yeah, it's just g to the 1, and we don't write the 1 at all. So it ends up being 16 q to the 6 g square root of 5. I'm really concerned about you this morning. I'm not going to lie. Really, really concerned. Yeah, apparently so. Okay, and now we get to our next problem, which I'm hoping we're a little more alive on today, because we would like to rock it out on our quiz, we would pray. So it's 8k and square root of k to the third. So there is nothing we can do to the 8. It's already outside the radical. It's escaped. I just need to know about the k to the third. What comes out, what stays in. Say it again, Hunter. Okay, but we've already been over this. We have already been over exponents with radicals, and to be honest, you already did it in Algebra 1 too. So you forgot it in Algebra 1. You forgot it when we went over it, and here we are again. It's 3rd time's the charm. How are we going to remember this kind of thing on the ACT? Or, God forbid, in college? What are we supposed to do with the odd exponents? What happened? So if worst comes to worst, what can I do?
You could.
Okay, so I write them all out, K, 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 and now what do I do? Pairs. So one pair comes out, so a K comes out. That guy doesn't have a pair, so he stays in. Are we supposed to have to do that?
No.
Are we supposed to be smart enough to realize 3 ends up being K squared, so we bring out 1K, and then we have the K left over? Yeah. Are we supposed to remember that? Absolutely. Oh, goodness. Table 3, thank you for your help. You can have a point. Whew, goodness gracious. I'm praying this next one goes better. Whew. Do not tell me 108, because 108 is not correct. Well, 100 is a perfect square, but there's a bigger one that goes into 800. 400 times what?
2.
Yes, and he said 400, so we're going to give him the point. And then I'll leave the exponents alone for a second. So what comes out of the radical number-wise? Thank you. 2 and 6 get a point, so it ends up being a 20, and there's a square root of 2 left there in the radical, but we've still got to deal with that a to the 4th, b to the 11th.
A squared.
1, 2, and 3 get a point, and then b to the what power?
To the 10? No.
B to the 5th.
And what's left?
B.
And Arturo, your group gets another point.
At this time, could we please have Key Club members and Diamond Dolls to the gym for pictures? Key Club and Diamond Dolls for
Okay.
pictures.
Number 12, and then I've got to go take a picture. How lovely. Okay, number 12. Number 12 is the one tricky one of the day, 289. Oh, God bless you, Mia. You can have 2 points for that. So 17, but then that's not even the tricky part. The tricky part has to deal with the exponents. It was a d to the 0, an e to the 5th, an f to the 9th.
D to the what?
0.
Is that even possible?
Anything to the 0 power is what?
0. 1.
Oh, God. Anything to the 0 power is 1, people, so we're going to completely ignore that d. Gracie's right. It was crazy. It was just there to throw you off. I need to know about the e to the 5th and f to the 9th. Yes, Arturo, please handle it.
E to the 2nd and f to the 3rd, which that will leave you e in the exponent.
And then I feel like this one's wrong.
No, it isn't, because 3 times 3 is 9.
Yes, but we're doing pairs. So you can have a point for the e, but f is wrong. Can someone tell me what I should have for the exponent with f?
Oh, f to the 4.
It's f to the 4 with an f left over, because 4 times 2 is 8, 8 plus 1 is 9, 2 times 2 is 4 plus 1 is 5. Yes, that is correct. So it should be 17e squared f to the 4, square root of ef. Arturo gets another point. Let me remind you of something that I need to do a better job of going over, and I will have to rectify tomorrow. If you've forgotten your perfect squares, bless your heart, because by the end of this 9 weeks, we're taking a perfect cubes test on 0 through 10. So I literally expect Mia to know that 2 cubed is 8, 1 cubed is 1, 3 cubed is 27. And no, they're not going to be in the exact order. So Patrick might memorize the order, and he'll be real sad 2 cubes at the end. So just FYI. Okay, I need you to clear up your desk. You don't need anything except a pencil. I need you to spread out. If you were not here yesterday, you do not have to take this. Although I swear it's just matrix basics, so you ought to take it.